Alright everyone, we're back here and we're now doing the same thing we've done the last couple days. We're trying to solve a system of equations, but we're going to do it a little different method here. This is totally without graphing. This is totally algebraic in how we're going to solve it. And you may say, well, you know, why do we have to do the same thing two different ways here? Well, because sometimes you're going to come across questions, maybe on a test or maybe on a state exam or something like that, where they say they want you to do it algebraically. They don't give you a graph or anything. So we need you to be able to do things multiple ways. All right. So we're trying to do the same thing. We're trying to see where do these equations, where do they have the same solution? Where would they cross if we did graph them? But we're going to do a little different today. We're going to do elimination method. Okay, and if you think of the word eliminate, that really means to get rid of something, right? To get rid of something out of, in this case, the equation. All right, so here's what we're going to try to do. We're going to try to take these two. Now, you notice these are not in the form y equals mx plus b. And all along, for weeks now, we've said put it in the form y equals mx plus b. Well, to do elimination method, you don't really need to do that, okay? What you need to do is make sure that your x's and your y's are actually on the same side of the equation. It just makes it a little easier. Alright? So notice these, if you put one on top of the other like I have it here, the x's really line up vertically, okay, and the y's line up vertically, and then the equal sign line up vertically, and then you have a number over here that line up vertically, and that's what you want. Alright? Before you do anything, you want that to happen. Okay? So, what we're going to do is try to eliminate one of these variables. Okay? And this one, very easy. What you want to do is either add these two equations together or subtract the two equations together. Alright? And hopefully that will get rid of one of the variables. So, what you really want to happen is you want one of these numbers, one of these coefficients, those big numbers in front of the variables, we call them coefficients. You want one of these numbers or these coefficients to be the same absolute value. Alright? So if you look in front of this x, you have a 1, and in front of this x, you have a negative 1. Well, if you take the absolute value, you get the same number. You get a 1. Alright? So that's what you want to happen. Alright? So this one, very easy. I can take these two equations. In fact, I'm gonna rewrite them over here. X plus 2y equals 13, and we have a negative x plus y equals 5. And I'm going to add these two equations together. All right. Now, do me a favor, guys. When you do this, whenever you do, whether you add them together or whether you subtract them together, put the parentheses that I just put in here. Put those out there. In fact, you know what? I'm going to do that in another color just to show you. This is the original equations that I started out with, these right here, and I'm going to add in this part. Okay, I'm going to add these two together. It just makes it so much easier when you're adding these to see what you're doing. Alright, so some of you guys will ignore me, but I really encourage you to do this because it just makes it so much easier. So now just add the like terms together here. We have a 1x up here, and we're going to add a negative 1x. Well, if I do that, that gives me a 0x. So these go away. That's the elimination method right there. You've eliminated the x's from the problem. Okay? In fact, I could write it right here. I get 0x. Alright? And then if I take 2y and I add, notice I'm always going down here and I'm always saying, what am I doing? I'm doing 2y adding a positive 1. Well, that gives me a positive 3y. Okay, my equal sign, well, that comes straight down, just like we do our algebra normally. Alright, and 13 plus 5, well, that gives me an 18 over here. So what do I have left? I've eliminated this 0x. I could even write it down here without that 0x. Now, doesn't that turn it into an equation that we know how to solve? We have one variable with one unknown. So now just solve that for y. So I divide by 3, Alright, on both sides, just doing my algebra, and over here I end up with y, and 18 divided by 3 is a 6. So I'm halfway there. I didn't answer the question totally. I figured out what y is. Well, now I have to figure out what x is. And this is super easy to do that. Once you get what y is, you then substitute. You go over here and you take one of these equations. Okay, I'm going to take the top one. Doesn't matter which one. I'm going to take the top one, and I'm going to substitute in what I got for y. Sorry, I'm going to substitute in to the equation. So x plus 2 times 6 equals 13. And now I'm going to just simply solve for x. So I get x plus 12 equals 13. I'm going to take away 12 from both sides, and x equals 1. Alright, so the solution to my whole system of equations here, my solution, I'm going to write that separate. Make sure you do the same thing. My solution is 1, comma 6. Okay, here's my 1, there's my x value, and here's my 6. That's my y value. Alright, so if I took 1 comma 6 and I plugged it into this first equation, if I plugged a 1 in for x and a 6 in for y, it will actually come out to be true. Alright, and if I take a 1 comma 6 and I plug it in for x and y over here, it will come out to be true. It will work itself out. Alright, that's how you check those. Alright, so with the elimination method, the key is, alright, first of all, alright, I'm going to make a little list here. Line up your terms. Okay, meaning line up your x's, line up your y's, line up your equal sign, line up your numbers over here. Okay. Number 2, add or subtract the two equations. Alright, I'll put line up and then add or subtract the two equations. Now sometimes you have to do a little work beforehand. We're going to get to an example where you have to do a little work beforehand before you add or subtract those equations. Okay. Number 3, solve for the variable. Okay, the variable that is left, you're going to solve for that variable. And then number 4, substitute. Okay, substitute that variable or that answer into one of the equations. That allows you to figure out the other variable. Okay, so really that list really kind of sums up the elimination method. Like I said, we're going to have some equations that we have to do a little work in between step number 1 and number 2, but we'll get to that in a minute. Alright, so let me clear the deck here. Let's go on to example number 2. Let me turn that one off and this one on. Alright, so exercise number 2, it says find the solution of the system of equations by elimination method. Alright, and again, we're going to try to eliminate one of the variables. Okay, so I asked myself, do I have it set up already so that I can just simply add these two together or subtract these two together? And what I look at is the coefficients. I look at the numbers out front here, and this is a 1, and this is a -2. Well, those definitely are not the same absolute value. So I look at the y's and I see, oh wait, look, that's a 1. And that's a 1, so that's definitely the same absolute value. Okay, now what could I do to eliminate the variables? If I add these two together, would it eliminate the variables? Well, 1 plus 1 would give me 2y, so that would not eliminate the variable. What if I subtracted these two equations? What would happen there? Alright, and again, put down these parentheses out here and put the subtraction, because if you don't, then it really gets mixed up. See that negative sign right there? It really gets mixed up with that one. Alright? So let's walk through this. I got a 1x minus a -2. Well, when I minus a negative, it's really adding. So I really have 1x plus 2. So that's 3x. And for my y's, I have 1 minus 1. So that, look at that, that becomes 0y. Alright? And then here, what do I get? 1 minus 4, so that gives me -3. Okay? So look at what happens. I eliminated that variable, because really this equation turns into that, because this 0y, that can really go away, right? So now that I've eliminated, there's your elimination method, right? So now that I've eliminated the variable, I can simply solve this for x. I can divide by 3, all right, and x is going to equal -3 divided by 3 is -1. Okay, so that is part of my solution here. Okay, so I take my -1, and I'm at the point in the last problem where I substituted in. So I take this -1, I substitute in. Again, I'm going to take this top equation. It doesn't matter which one you take. You just take one of those equations, and I'm going to substitute in the -1. The -1 is the x, so I'm going to take the x out, and I'm going to plug in this -1. And now look at what I have. I have one equation with one unknown, so I can solve for y. Okay, so y equals 2. So my solution is going to be, what's my x value? My x value is over here. My solution is -1, and the y value is 2. So my solution is -1, 2. And there you have it. All right, we've solved for each variable there. All right, so let me turn off this one. Let's go on to number 3 here. All right, now here, this is the one that it's going to be maybe a little more difficult to eliminate the variable here. All right, because if I look at these, notice that the x value is the coefficient in front of the x is 1 here and a 5 there. Well, those definitely are not the same. And this one, it's a -4 there and a 9 there for the y, and that's definitely not the same. So what I have to do is I have to fix it so that I can add or subtract these. Well, remember what you can do with equations. You can always multiply through a whole equation by a number, and as long as you distribute to each term, you're not really changing the equation. All right? So we're going to change this one. We're going to change, I think the easiest thing here, what if I multiplied this top equation by 5? Well, that would make that a 5 in front of that x, and then I could subtract them and eliminate the x. All right? So that's what I'm going to do. I'm going to write a little arrow here, and I'm going to, and let me write it out so you see what I'm doing. I'm going to multiply this whole equation by a 5. All right, and that, whoops, that's an equal sign there. So we're going to distribute that 5. So 5 times x is 5x. 5 times -4 is -20. And 5 times 7, and this is the part that people always forget. They forget to distribute to the other side of the equation, right? So what I did, if you want to draw in your little arrows here, I distributed this 5 to each term across that equation. All right, that's okay. I can do that because that gives me the same equation. All right, it's an equivalent equation. Now this bottom one, I'm not going to have to multiply anything by. There may be problems in the future where we might have to multiply each one by a number, but this one I don't have to change because I already have a 5 down there in the bottom. Okay, so that one doesn't change at all. Alright, so what can I do to these two equations? Well, since these two are both 5s, if I add them together, I'm going to get 10. But if I subtract, right, if I subtract these two equations, then 5x minus 5x is 0x. So that's good. There's my elimination. Alright, now watch your positives and your negatives here. -20 minus 9 would be -29y. Oh, I forgot a y up there, didn't I? That would be a y right there. Okay, and 35 minus 6, that is going to be 29. 29. All right, so my whole equation, if I take out this 0x, my whole equation boils down to that. And now we can just solve for y here. We can divide by -29, divide by -29, and I get y equal to -1. Alright, so now what point are we at? We've figured out what one of the variables is. Well, now I can take that -1 and substitute it in. Again, I'm going to take this top equation. Not that I have to, but it just looks like a little more easier to work with. And I can plug in a -1 where I see the y value, right? And now look, I've got an equation with one unknown. -4 times -1 is +4. Okay? And then I'm going to take away 4. Take away 4. That is not a 4. Take away 4 on both sides, and I get x equals 3. So my solution, right? My solution is 3 for my x value and -1 for my y value. So that's the solution. If I graphed these equations, that is the point where they would cross. Alright? Alright, let's try one more. Okay guys, here is number 4. So we want to do the same thing here. We want to solve the system of equations by elimination. And I'm going to do the same as what I did before. I'm going to look at these coefficients right in front here and say, well, are they the same? Alright, are they the same absolute value? And obviously those two are not. That's a 4 and a 1. Obviously those two are not. That's a 37 and a 7. So I'm going to have to change one of these equations so that they are the same. Alright, and it looks like the easiest thing to do here, oops, we don't want that thing on there. It looks like the easiest thing to do here is to multiply this bottom one by a 4. Okay, so let's do that. Let's go 4 times x plus 7y equals 4. And I'll draw in my arrows so that we all know what we're doing here. We're going to connect, connect, connect. We're going to distribute those, okay? So what am I going to end up with? I'm going to end up with a 4x here and a 28y there and a 16 there. Alright, this top equation I'm not going to do anything to. I'm just going to bring it right across here. And I'm going to go 4x plus 37y equals -11. Okay? And what can I do to these two? Again, if I add them, 4x and 4x is going to be 8x. That's not going to eliminate that variable. And 37 plus 28, that definitely isn't going to eliminate that variable. So I'm going to subtract these. Alright, I'm going to put in my parentheses and my subtraction. So 4x minus 4x, well, that's going to give me 0x. 37 minus 28, well, let's see, what is that going to be? 37 minus 28, isn't that going to give me 9? Right? 9x, or 9y, I should say. Alright, and let's see, be careful your negatives here. -11 minus a 16, well, that's going to give me -27. Okay, so my whole equation boils down to 9y equals -27, and that's good because that is one equation with one unknown. I can solve that. We've done that forever, it seems like, and I'm going to get y equals -3. Alright, so now what can I do? I can plug that into one of these. You know what? I'm going to take this second equation here because it looks like a little easier to deal with here, but it doesn't matter. I can take the other, but I'm going to plug in a -3 in for my y value because y is -3. And then I'm just going to do my math and see what I come up with here. Oops, that's actually going to be a negative, right? So positive 7 times -3, that gives you a -21. Okay, and then I'm going to add 21 to both sides. And what do I get for the value for x? For a -4 plus a 21, that is actually positive 17. Alright, so my solution, right, my solution is going to be the combination of those two. My x value is 17 and my y value is -3, and there you have it. There's the solution to that set of equations. Again, if I graphed them, they would cross at the point 17, -3. Alright, so there you have it, guys. Hopefully that went well. Thanks for watching, and we'll see you tomorrow.